Okay, we are now on to part 5 of our video series on the chain link challenge. I've gone ahead and made a modification to my chain link. I went ahead and extended this side from 15 to 20 millimeters from this end to this end, and it worked out just fine. At least so far, I haven't added a compression pin yet. That is this video. We're going to be creating a compression pin. I've got this open just so that you can see it. It's pretty much done. I'm going to go ahead and open it up and hit the edit sketch. And the reason I went ahead and added the edit sketch is I'm going to go ahead and hit Smart Dimension real quick, and I want to show you this right here, which is the groove part of the entire project. And it is 20 millimeters wide. I need to keep that number in my head. Go ahead and just down to that. And I need to go ahead and, oh, that's not what I want to do. And I'll need to remind myself that these circles here are 7 millimeters in diameter. Thinking, okay, what's that got to do with anything? Well, this is what I'm going to do. I'm going to create a new part without closing out my link. So I'm going to create a new part. And it says IPS. I need to go to MMGS. Pick out one of these here. This is going to be a relatively simple design. It's not really all that extravagant. I'm going to start off with a circle. You zoom in. Went ahead and put the center on the origin point. Smart Dimension. Not going to go 21 millimeters in diameter. It's going to go 7, and I'm going to go ahead and start off with 6.8 millimeters. That is going to account for the plastic that has been expanded. So that is the sketch. That's it. Do extrude boss base. And I'm going to make that 20 millimeters. Oh, I wonder where that came from. Oh, yeah, that came from the fact that the length, the width of the pin, which is the second, is 20 millimeters. My length is 35 and the extrusion is 10 millimeters. So 6.8 diameter, 20 millimeters length, and that's all I need to do. That is as simple as it gets as far as design. I'm going to add a 1 millimeter chamfer, which is like a fillet, but it's going to be a flat edge to one end. 1 millimeter. There, just so it has an easier time going in. We'll try that. I might remove it later. I don't know how it's going to work out. So I'm hoping that this will be the only version that I'm working with, about 0.2 of a millimeter less. The reason I got that is because when I went over to my my links, I grabbed a caliper, dowel caliper off the Elmo cart, which is on the second. It's on the second shelf of the Elmo cart, and measured the inside hole, and it said 6.8. Now keep in mind that that is going to be a warped measurement, but it is something that I can at least start with. I'll go ahead and save as. Pin. Just going to go into my thumb drive, CLC folder. There is the link. So now I got the compression pin. So there's 2 files there. And I'm going to go ahead and save as an STL. Okay, make sure it says TL. It is, and save. And you can see the number of triangles that it's making right now. Now, I've had some students save the STL to the micro SD card. Don't do that. Save it to the exact location of your parts file. Okay, let's go ahead and open up Cura. And I'm also going to go ahead and get a micro SD card. I'll be right back. Okay, we are back. The Cura has loaded up. I'm going to go ahead and insert my micro SD card into the converter and go into the front of the computer. I'm going to go ahead and delete that. And I'm just going to go ahead and minimize that. All right, now I'm going to go ahead and go to my thumb drive in the CLC folder. I'm going to pull the pin. I'm not going to pull the link. I don't need the link. Okay, a couple of problems with this. Let's get a little bit closer. First problem that we have is that it is standing straight up. So we're going to have to go ahead and click to activate it. And we're going to rotate it where it is 90 degrees down. Now, second problem we have is that that is the contact point. And that's not what we want. So I'm going to make a few movements here. I'm going to pull it this way a little bit and push it that way a little bit. Second thing, or third thing, we don't want to have just one pin on here because this is going to get too hot. It's going to warp and it's going to do all kinds of crazy stuff. Each layer needs to cool a little bit before the printer comes back. So I'm going to need to create a second one. I'm going to go ahead and click it, bring it down to about the same plane and move it all the way to the other side. That's about how far I need to be. That way you got a layer being printed here, then it goes over here and prints a layer. Now, there is a problem with this. That's a very, very small footprint. So the pin is not guaranteed to stay in place, but we're going to help it. So we're going to go to Build Plate Adhesion. You should have none here. And you're going to select Raft. You don't need supports, just a raft. Now we're going to go ahead and slice. We'll go ahead and preview so you all can see what this thing looks like. And that's what it looks like. It won't take but 16 minutes once it starts printing. It has to take about 4 to 5 minutes to warm up. Let's go ahead and see where this is going to save. Okay, so it's supposed to save. It's not showing me. Let's go to Prepare. There we go, Ender G-code. So I'm going to save it to the Ender G-code SD card. So we're going to do 2 every time that we're going to do a test print. We're going to use one of these as our actual model to see if it fits. Now the whole point is for the pin to go in and stay in. Hopefully that will work. We shall see. All right, so there it is. This is due by Friday, April the 5th. Good luck.